Hello science fans! Let's talk about something that's in you, in me, in the pizza you had for dinner, and even in the air we breathe. It's an element, a basic ingredient of our world, called carbon. Carbon is like the ultimate Lego brick of life. Everything that is alive or was once alive is built with it. Your hair, your fingernails, the leaves on the trees, and the fuzzy caterpillar crawling on that leaf, all of them are packed with carbon atoms. It's the super special ingredient that makes life on Earth possible. Without carbon, our world would be a very, very empty place. It's not just in living things, it's everywhere. Now you might be wondering, if carbon is in so many things, how does it get around? Well, it travels in a fantastic planet-sized loop called the carbon cycle. Think of it like a giant recycling program that Earth has been running for billions of years. The same carbon atoms that were once part of a mighty Tyrannosaurus Rex could be in the apple you're eating today. The carbon cycle moves this essential element from the air to the land, into the oceans, through all living creatures, and back again. This constant movement is incredibly important because it keeps the amount of carbon in different places in a delicate balance, which in turn helps control our planet's climate. This amazing cycle isn't just about moving building blocks around, it's also about energy and temperature. One of the most important forms of carbon in the air is a gas called carbon dioxide, or CO2. You've probably heard of it. This gas acts like a cozy blanket for our planet, trapping heat from the sun and keeping Earth warm enough for us to live here. The carbon cycle makes sure we have just the right amount of this blanket, not too thick, not too thin. It's a natural thermostat for the whole world, and understanding how it works is one of the most important things we can do as citizens of this planet. So, let's get ready to explore this incredible journey. We'll follow a carbon atom as it zips through the air, gets eaten by a plant, travels through the food chain, and dives deep into the ocean. It's a story of chemistry, biology, and geology all rolled into one. It's the story of how our living world stays alive and in balance. By learning about the carbon cycle, we learn about the very pulse of our planet. It's a big deal, and it's happening all around us, all the time. So put on your thinking caps, because science is about to get awesome. So, where does our planet keep all of its carbon? It's not just floating around randomly. Earth has 4 main storage lockers, or reservoirs, where it stashes its carbon. The first and most famous one is the atmosphere. That's the big blanket of air surrounding our planet. Carbon exists here mostly as carbon dioxide, or CO2. While it's only a tiny part of the air, this atmospheric carbon has a huge job. It helps regulate Earth's temperature, making it a key player in our climate story. Think of the atmosphere as the fast lane of the carbon cycle, where carbon atoms are always on the move, ready to be grabbed by plants or dissolved in the ocean. The next big carbon container is the biosphere. That's a sciencey word for all the living things on Earth. From the tallest redwood trees to the tiniest bacteria in the soil, every living organism is made of carbon. Plants are the champions of carbon storage on land. They pull it right out of the air to build their leaves, stems, and roots. Animals, including us, get our carbon by eating plants or by eating other animals that ate plants. So you are a walking, talking carbon reservoir. When living things die, the carbon in their bodies is ready for the next step of its journey, which is pretty cool. Of course, we can't forget the biggest carbon storage unit on the surface of the planet, the hydrosphere, which is all of Earth's water. The oceans are like a giant sponge for carbon. They hold way more carbon than the atmosphere, and all the plants on land combined. Carbon dioxide from the air dissolves into the ocean's surface. Once it's in the water, some of it is used by tiny marine plants called phytoplankton, which are the base of the ocean food web. A lot of it just stays dissolved in the water, and some of it slowly sinks to the deep ocean, where it can be stored for hundreds or even thousands of years. Finally, we have the heavyweight champion of carbon storage, the lithosphere. This includes the rocks, soils, and fossil fuels in Earth's crust. This is where the vast majority of our planet's carbon is locked away. Over millions of years, the remains of dead plants and animals get buried under layers of sediment. Intense heat and pressure transform these remains into coal, oil, and natural gas, what we call fossil fuels. Other carbon gets locked up in rocks like limestone. This carbon is in the slow lane of the cycle. It can stay trapped underground for millions of years, safely out of the atmosphere, until something, like a volcano or a human, releases it. Now that we know where carbon hangs out, let's look at how it moves. The carbon cycle is a beautiful, intricate dance with some key steps that keep everything flowing. The first big move is called photosynthesis. Plants are the star dancers here. They breathe in carbon dioxide from the atmosphere and use sunlight as energy to turn it into sugary food for themselves. This process locks carbon into the plant's body, building its leaves, wood, and roots. It's nature's amazing way of taking carbon out of the air and turning it into life itself. Every blade of grass, every giant tree is doing this dance right now. The next step in the dance is respiration, and it's the opposite of photosynthesis. It's what you're doing this very second, breathing. All living things, including plants and animals, perform respiration. We take in oxygen and use it to break down the carbon-based food we eat to get energy. When we do this, we release carbon dioxide back into the atmosphere as a waste product. So as you breathe out, you're returning carbon to the air, completing a small part of the cycle. Plants and animals are constantly breathing, creating a steady flow of carbon back and forth between the biosphere and the atmosphere. What happens when plants and animals die? That's when the decomposition dancers take the stage. Decomposers, like fungi and bacteria, are nature's cleanup crew. They break down the dead organic matter, feasting on the carbon stored in it. As they do their work, they release some of the carbon back into the atmosphere as carbon dioxide through their own respiration. The rest of the carbon gets mixed into the soil, where it can provide nutrients for new plants to grow, or eventually get buried and become part of the rock layer. This process is vital for recycling nutrients and carbon back into the ecosystem. The ocean has its own special dance moves too. Carbon dioxide from the atmosphere dissolves directly into the seawater. Tiny marine organisms like phytoplankton use this carbon for photosynthesis, just like plants on land. When these organisms and other marine creatures die, their carbon-rich shells and bodies sink to the ocean floor. Over immense periods of time, these layers of sediment get compacted and turn into rock, like limestone. This process, called sedimentation, locks carbon away at the bottom of the ocean for millions of years. It's one of the planet's most effective ways of storing carbon long-term, keeping our climate stable. For millions of years, the carbon cycle's dance was perfectly choreographed by nature. The amount of carbon going into the atmosphere was roughly equal to the amount coming out, keeping the planet's climate in a happy balance. But then a new dancer jumped onto the floor: us, humans. Over the last couple of hundred years, our activities have started to change the rhythm of the carbon cycle in a very big way. We began to move huge amounts of carbon from its long-term storage in the lithosphere and released it into the atmosphere. And we did it very, very quickly. It was like turning up the music at the dance party way too loud. The biggest change came from our discovery of fossil fuels. We found that we could dig up all that carbon that nature had buried for millions of years in the form of coal, oil, and natural gas, and burn it for energy. This powered our factories, our cars, and our homes. It was a revolution. But every time we burn these fuels, we are taking carbon that was locked safely underground and pumping it directly into the atmosphere as carbon dioxide. We are basically speeding up a natural process that would normally take millions of years and cramming it into a few decades. At the same time, we've been messing with one of the most important carbon removers: forests. The act of cutting down huge areas of trees is called deforestation. Trees are fantastic at breathing in carbon dioxide, so when we clear forests to make room for farms, cities, or roads, we are getting rid of our best natural allies in the fight to keep carbon in balance. Not only that, but when trees are cut down and burned or left to rot, all the carbon they had stored in their wood is released back into the atmosphere. It's a double whammy. We lose the carbon eaters, and we add more carbon to the air. Even our farming practices have changed the carbon cycle. Plowing fields can disturb the soil, releasing stored carbon into the air. Some fertilizers we use can also release powerful greenhouse gases. And our livestock, like cows, release methane, another carbon-based gas that is very good at trapping heat. All of these human activities, burning fossil fuels, deforestation, and certain types of agriculture, have added a huge extra pulse of carbon into the atmosphere. We have interrupted the natural dance, and the consequences of that interruption are becoming clearer every day. The planet is starting to feel the effects of our clumsy footwork. So, what happens when we pump all this extra carbon dioxide into the atmosphere? Remember that cozy blanket we talked about? Well, by adding more and more carbon dioxide, we are making that blanket thicker. This is what scientists call the enhanced greenhouse effect. The blanket gets better at trapping heat from the sun that would normally escape back into space. A little bit of this effect is good, It's what makes Earth livable. But we've added so much carbon dioxide that the blanket is now too thick and the planet is starting to overheat. This warming of our world is what we call global warming or climate change. This extra heat doesn't just make our summers a bit warmer, it throws the entire Earth system out of whack. It causes glaciers and ice sheets at the poles to melt faster, which in turn causes sea levels to rise. Rising seas can flood coastal cities where millions of people live. The extra heat also leads to more extreme weather events. We are seeing more powerful hurricanes, more intense heat waves, heavier rainfall in some areas, and more severe droughts in others. The delicate patterns of weather that we have relied on for centuries are being disrupted by this imbalance in the carbon cycle. The ocean, our giant carbon sponge, is also feeling the strain. As it absorbs more and more carbon dioxide from the air, the chemistry of the seawater starts to change. The water becomes more acidic, a process called ocean acidification. This is very bad news for many marine creatures. Animals like corals, clams, and oysters use ingredients in the seawater to build their protective shells. As the water gets more acidic, it becomes harder for them to build those shells. This threatens entire ecosystems like coral reefs, which are like the bustling cities of the ocean, supporting a huge amount of marine life. The entire web of life, the biosphere, is being affected. Plants and animals are adapted to live in specific climates. As those climates change, many species are struggling to keep up. Some are trying to move to cooler areas, but not all of them can move fast enough. This can lead to a loss of biodiversity, which means we lose the amazing variety of life on our planet. The delicate timing of nature, like when flowers bloom and when birds migrate, is being thrown off. The balance that the carbon cycle maintained for so long has been tipped, and the consequences are rippling through every part of our planet's systems. The situation might sound scary, but here's the good news. We are a planet of problem solvers. Scientists, engineers, and citizens all over the world are working on incredible ways to help fix the carbon cycle and restore its balance. One of the simplest and most powerful solutions is to work with nature. We can help the biosphere do what it does best: absorb carbon. This means planting billions of trees through reforestation and afforestation projects. More trees mean more photosynthesis, which means more carbon dioxide pulled out of the atmosphere and stored safely in wood and soil. It's a natural solution that also creates habitats for wildlife. We also need to protect the carbon-storing ecosystems we already have, especially our oceans and wetlands. Protecting marine habitats allows phytoplankton and other sea life to continue their crucial work of absorbing carbon. Healthy coastal ecosystems like mangrove forests and salt marshes are amazing at capturing and storing carbon in their soil, a process known as blue carbon. By preserving these powerful natural allies, we can ensure they keep doing their part in the carbon cycle. It's about giving nature the space and protection it needs to heal itself, and in turn, heal our planet. Of course, we also have to slow down the amount of new carbon we are adding to the atmosphere. This is where technology and innovation come in. We are getting much better at harnessing clean energy from sources that don't burn fossil fuels. Think of giant wind turbines spinning in the wind or vast fields of solar panels soaking up the sun's rays. By transitioning to renewable energy, we can power our lives without releasing all that ancient carbon. Scientists are also developing amazing technologies like carbon capture, which can grab carbon dioxide from power plants before it even reaches the atmosphere and store it safely underground. Ultimately, everyone has a role to play in this global effort. Making smart choices in our daily lives like using less energy, recycling, and supporting businesses that are environmentally friendly all adds up. The most important thing is to stay curious, keep learning, and talk about it. The carbon cycle is the story of our planet, and right now, we are writing a very important chapter. By understanding how this incredible system works and how our actions affect it, we can all become better caretakers of our amazing home. Protecting the carbon cycle is about ensuring a healthy, stable, and wonderful future for everyone. Consider the science.